Okay, go ahead.
This is going to be a little simulation I've been working on. I've done some
Who are you?
following simulations.
Who are you?
Who am I? Oh, goodness. I'm a representative of Polo, the place to buy your stuff for robotics. Anyway, I do have one of their shirts anyway. I'm not a representative of Polo, but I do like your stuff.
Yeah.
Anyway, what I have today...
You still haven't told us who you are.
Okay, take 3. I am Ron Grant, a longtime member of DPRG, and anyway, one of my passions is computer graphics, and for years and years I've played with 3D simulation and stuff like that. So what I'm doing now, besides listening to a car alarm, is doing some stuff in processing, which is Java-based.
Yeah, sit down. Yeah, click your face. That's another button.
Anyway, so I'm just gonna really just kind of pretty pictures for now. I guess last month we did some presentation stuff on line following simulation and stuff like that. Well, today I've just got a computer graphics simulation, but I'll kind of describe what's going on, so we'll get it started. And unfortunately, probably stuff is not scaled correctly to show up very well as far as, oh yeah, information there. Let's see if we're going to get a break. In the far upper right, I might be able to fix that, but you might be able to zoom in on it, is really a virtual camera view of the robot. So the robot here that we're seeing is trying to place there. It's placing a can, and there's a little faultiness in that there's no obstacle detection. But here it's actually looking with a virtual camera and spotting the cans and using really the same stuff that I run on my real robot. But it's having a little difficulty. It might have something to do with the resolution of the screen here is quite high, and that might be introducing some difficulties. I don't know. Anyway, let's see. Yeah, we did spot that. But in the far corner is the camera view, and I might be able to make a change to that so we could do a cut and people can carry on enjoying
I like the music too. I like the music.
Oh yeah, it's sort of some weird stuff I got on YouTube. Anyway, some real bizarre stuff. Anyway, this robot does have perfect odometry though, and somebody, let me see if I can turn that down. That's kind of strange music. So this robot knows where it is without having to do any realignment, and it ran right through a can. Yeah. Okay. So it's using a virtual camera to render a view of what it sees in the upper right, and so it's doing blob detection just as I would with my real robot. So my little robot does or was able to do this a few years ago until the code broke. Somewhere I think there's code rot, yeah. But my goal here is to really integrate my simulation code written in processing and run it on board a Raspberry Pi and sort of fuse my simulation with my original code, if that makes any sense. I did do a long time ago a similar simulation written in Object Pascal or Delphi, but I've kind of transitioned to Java over the last few years. So I guess doing some Android applications, I decided I'd just write stuff in Java.
So your simulation and your actual robot had a camera that was kind of outside the field?
Yeah, oh no, sorry. What we're actually seeing in the far upper right, if we could cut the resolution down on this, that might be a tall order. Okay, because this monitor's running at 4K.
Oh,
and I kind of designed it to run really at 1920 by 1080 HD. But anyway, so what we're seeing is there is a camera view in the far upper right.
of the robot.
Yeah. Do you see that up there?
Yeah.
Okay. And that is from the perspective of the camera. So what we're seeing is really a view, whatever, like you stand, 6 feet above. Has nothing to do with the robot. It's really processing all its information based on what it sees in the window, but it does have real good odometry. And the problem with that is, in real life, I could stack 6 cans like that, but as you know, as you run around, you build error. And I think one thing that let me, with my real robot, which is stepper motor based, I think one of the things that allowed it to not have such large errors in odometry was I would execute a limited number of turns. Whereas in this case, as I'm acquiring a target, I'm making corrections on the fly to my rotational rate of the robot. But in real life, what I would do is I would turn the robot and then drive, acquire the object, and then so make limited numbers of turns and not do on the fly curved, swept or variable radius curves. So anyway, so this robot, in real life,
He ran out of cans, so he's just doing his own thing now.
He picked one up and now he's moving it somewhere else. It's after close to the wall.
Yeah, so.
What simulations are
Busy
there?
with
Easy.
that.
Pick 'em all
Oh, and
again.
this, by the way, the robot, the band around the eye represents my real eye, which has a encircling buckle thanks to a torn retina. So I kind of made my robot like me. It has a silicone band around its eye, which is kind of inflamed and red.
Yeah, it looked like one of those videos.
But then it can go through walls.
That's a nice
But
Okay,
anyway,
What is the simulation?
So it looks like the graphics
Yeah.
town.
so what I
In college, I took a graphics
Really what
class,
I-
and that class was completely
the shoulders.
open-ended, and the senior project was to build a town.
oops, hang on. Sorry.
That's approximately the level that
Go
the towns look
ahead.
like.
Yeah, I'm not very good at anyway, the framework I'm using is built on OpenGL, and processing itself provides we'll say the interface to OpenGL as far as it simplifies some of the things you do as far as setting up a camera, a virtual camera, and the three-dimensional geometry. In this case, is very simple. So things like cubes and whatnot. But really, the simulation, I am at least creating everything that's not just low-level OpenGL, we'll say. So it's not that complicated, but it does require, some fiddling with the idea of understanding how to do hierarchical transforms in 3 dimensions, where the robot would be composed of different components and they would be translated and rotated about the robot.
Have you ever seen Unity?
I played with Unity a little bit. In fact, I should go back to that because one of my interests, all this stuff I run is virtual reality now. And anyway, I've managed to get the stuff I needed in processing to do virtual reality, but Unity is probably a great platform.
Unity ML, which is it's actually dedicated extension functionality. And I played with it a little bit, and I've got I've got a Roomba, the Roomba development kit thing. So I wanted to see, could you train it in Unity and then do something similar in the real world? But in Unity, I was quite successful with that. And they had this thing called imitation learning. And so I found a library of kind of fake rooms, indoor things, and I could train it with like 3 passes of going through a room to get to a waypoint. And with 3 training sessions of just 3 times manually controlling this robot to get to a waypoint, and then you run the machine learning algorithms, and they could do it on its own.
Okay, so this is all within Unity, but it is running a virtual camera in the Unity world, and it's using that as its information.
Yeah, I mean, you could build something very similar to that very quickly. What's interesting though, and is this, what interests me is this kind of simulation to reality thing. What you built there, you could move easily, I think, into reality.
Right.
Well, that's the advantage of what you've done here.
Right, and then that's kind of, I sort of worked a little bit backwards originally because I do have it, not with me today, but I have the robot, and but I use really like the blob detection, all that stuff. That code is all the same as I'm running on my own. Actually, I'm lying a little bit. I was using a Pixie Cam originally for the, at least in mid phase, for doing the blob detection. But then I also use the Raspberry Pi. In fact, I can, just quickly, we'll see if this will, if I can demo this. I might be able to show you also, just for fun, the advanced line following course. Let's see. So a little different application. We'll see if it runs. I may be embarrassing myself.
That's not possible.
Here we go. It may or may not run, let's see if I've got it.
Space.
Yeah, let's see if we can see it go. It's backing up right now. Up in the far right corner, you're seeing its view. I'm cheating a little in the view you're seeing. I made everything blue. I've been playing with projecting, and they're kind of trashy. The little cubes. Oh, in fact, I have an error of that. I'm not following those little glitched cubes. That's supposed to be where it's looking ahead of the line, but I've got a difficulty in my transforms right now. But there it detected whoops, and it screwed it up. A convex turn. It actually got it right.
You're going to have to talk slower, Ron, so that you can let the thing resolve itself.
That's it.
It's not a bug, it's a
Doing
feature.
just fine. Anyway, but again, here we're using a virtual camera. Oh, and sort of some cool, like, okay, this whole thing now is in a 200-foot sphere with stars mapped around it, just for cool effect when you're in virtual reality. And there's a little floating DPRG logo, and in virtual reality you can really see it hovering there. And it's really a lot of fun because you can make the course as big or small as you like. And you can stand right there and feel like it's the real thing, or you can feel like the thing's going to run you over.
So you put your VR goggles and just stand on the course, do you?
Yeah, or put it up at waist level,
Yeah.
or put yourself, make it really huge where the thing's running you over like a VW bus.
Did building this VR simulation actually allow you to create a vision algorithm that worked on the course?
Well, I'm using the same code on my robot, and you'll see that this may or may not be working so well. But this thing is,
did you make it work on this model and then take it out in the real
I
world
kinda
and
worked-
have it work perfectly?
no. But similar problems, and I wouldn't say that my simulation is perfectly aligned with the real robot, but during development I worked back and forth, and I really do like to work with simulation, although you end up with different problems. But I mean, this is truly, in the simulation, I am generating steps. I'm only generating 60 frames to 120 frames a second visual, but I'm really generating those steps, and I really could add in the bits of error that I end up with when I do, these steps. So really, and this one doesn't care about odometry though, because we're following a line. So, but in the case of the soccer robot, their odometry is important, and so reacquiring information about where the robot is via hitting whatever.
So what are these little boxes that are appearing?
Oh, those boxes are an indication of where it was detecting what it thought was either a convex or an acute angle, I'm sorry, or let me think what the other box is for. I can't remember. It's been quite a while.
Problematic things. Huh?
Yeah.
Okay,
Oh, the other
hey
thing-
Ron,
oh.
looking at your virtual camera, you have 3 lines going across and a
And a curve.
and a 180-degree arc.
Yes.
Okay, and looking at the vertical lines, they look like they're tracking the spot where the 3 dots of the horizontal lines cross. Is that correct?
Well, it's difficult to say that. I'm probably using I have the 3 different intersections, of the image of the line.
Yeah.
And I think one of the main ones I use is the curved scan line, but there are cases when I use the other lines. And so, as we can see here, I goofed on I goofed on the gate, but at least the line tracking is pretty good.
Yeah.
Anyway.
This is really cool.
Yeah.
So, in actual robot on course, how does it do? Have you tested it? Or?
Yeah, it's been a while. I need to get back to the real robot. But
He's going to trounce us next
But
time.
the thing that we were talking about last meeting, where we were, let's see if I can say this, Will can probably correct me, where the robot was, what it was doing is it was looking ahead and placing cookie crumbs on the line as it perceived it, such that as it moved closer to those cookie crumbs, it would react to those. In other words, it saw the line in the distance, and of course one benefit, I guess Will would mention, if there's any latency issues, it can be helpful to be able to see, to put those cookie crumbs down, because then as we move in closer, we can follow the cookie crumbs that we've laid into effectively what is, like these green cookie crumbs, are being dropped into, we'll say, the world coordinates. They're being dropped into the same coordinate system using, that the course is laid out in. The origin happens to be somewhere up here. And so, but you can see, this is my projected cookie crumbs, and I got a problem.
Yeah.
They're all over the place, and that's because I made some changes in this to tie it into my virtual reality stuff, and I had a lot of problems.
So this is really running on your sensors
But
only?
yeah, this is truly, not following what it's perceiving with its video camera.
So in this case, but that's probably pretty realistic. You won't have so much latency if you're just on a Raspberry Pi or something.
Not too much. Yeah, I think I was getting somewhere around 10 to 20 frames a second with
Yeah.
my current.
But I still don't understand. Okay, so you got four bars, so you're making a decision on the 3 horizontal lines and the circle.
Right. And
Okay.
I couldn't tell you right now, I have a priority scheme, and there are certain cases where I'm more concerned about when I have confusing information, particularly transitions where there's reverses. Those can be confusing for a brief second. Let's see if I can get in here. Pause it. There can be cases where, like a case like this, it can be a little confusing, deciphering what you're seeing, and you end up with, you think you see a line, and you get this complicated mess. And I think a lot of times my reaction to that is I go ahead and keep on going and not and say, I don't understand this, so we'll
Just go straight.
we'll just go straight, that sort of
Yeah.
thing.
It'd be interesting to put this map into the donkey car simulator and make it scale it up. The problem with the donkey car is it cannot do those tight turns. The
Oh,
difficult
yeah.
donkey car, you can make a radius of like this probably. But if you scale up that in the simulation, it'd be interesting to see how the donkey
Oh,
software
yeah,
and your
yeah. If
network
it could learn all the visual patterns
Yeah,
that were
you'd
there.
have to manually take it around the track, multiple times, which would be incredibly boring.
I would think that would be a
You must
trend.
use this to let it
Yeah,
drive.
if
right?
you use this to do it. Yeah.
And you get it, it's trained
That
out.
would be
Doug and I
pretty cool.
tried that, it didn't work so well. It went a few feet, just came to it.
Yeah, it's interesting, you
Yeah.
told me that, because I had a similar problem with a new donkey car I built, and it stopped. And I thought, this is exactly the same problem you were describing.
Yeah,
But
Sounds like-
in the training, right, there is no stop.
right.
So the neural network is basically something else is broken. And why I was using the wrong type of commands to train it. And once I figured that out, because I was also learned how to train in the cloud, which is a lot faster,
Oh,
and it would never stop. So it'd be interesting to try it again sometime.
yeah. Well,
So at this point, you're now laying down doubles of
yeah,
the
yeah.
past picture. It's not realizing that,
Oh,
right?
right, it doesn't see the crumbs. Though, sorry, I should mention, the green crumbs are invisible to the robot. What it really sees is in the upper.
Right, so like it has it figured out, I've traversed X amount,
Right,
I'm
no,
definitely done.
No, yeah, I mean,
Okay.
I could, let's see.
so you're not using those as waypoints, you're just using them as markers to indicate how well it's.
Yeah, exactly. So, yeah, the other stuff we were seeing, the little pink looking things that were all over the place, those are part of an algorithm to look in the future, see the line out front. And then, of course, that relies on the robot having reasonably good odometry, at least long enough that those crumbs, when they come into view, will be appropriately in the right spot, if that makes sense. In other words, if I see something, that chair right there, and I say, okay, it's 8 feet in front of me, my odometry has to be reasonable for me as I approach. I say I've gone 6, 7, 8, okay, good. So it's where I expect it to be. So that's kind of that. But yeah, the green crumbs are nothing, they're just visual for us to see how well it's tracked.
In the actual robot, on the curved line, are you looking at individual pixels that make up a curve?
I'm looking at intersections of that curve with the line. So you can just about flatten it out. It's still a scan line, but it just happens to be. So in other words,
Well, what is the purpose of that, Ron?
Your
Why the
full
curved
color
line? What does that bring to the party?
oh, well, and I think this came
Right
from
angles.
Will. Yeah, it's a great way to catch right angles.
Yeah.
So as we move in, like here, coming up on the right angles.
But you have to be addressing individual pixels because your line's not gonna be that curved, right?
Well, no, but it's still, if you think about it, it's still good at generating an error, and when you flatten that out, it's not bad. Let's see if we get to a right angle. Let's see.
You just went through two.
I should have the ability to clear all my crumbs. Wait a minute.
Here's one. Oh,
There you go. Don't know which way it's going there. Wait, does it come to right angle? I have somewhere right.
Yeah.
Well, it's never that worried. How about the acute angle? Wait a minute.
Yeah, it's
Okay,
kind of
go.
a way of looking around both corners.
Oh,
at
what's
the same
now?
time.
My problem there, oh, it's doing a calibration sequence. I have to take it back. I forgot. It backs up, and what it's doing is it's actually measuring the start line. It's getting information, and that has to do with this crumb projection thing, the little red crumbs out there. See the glitch. So that Ron's got a glitch. So it's thinking they're not where they are.
okay, so
So here
you,
we come. Here's an example of the curved, or a good use of the curved sensor thing. Well, you know, is that such a good one?
Yeah, it's
That's
catching
okay.
one side of the
You know, I
line.
think I might use the individual scan lines for that, because that's where you start to see multiple intersections getting closer and closer together. That's a
Right.
great one for that. But when we come to, oh, here's a right angle. Okay, once it's, don't ask me what it did here.
oh, it comes back.
Oh, I know. It turned the wrong direction. It's a long story, but I had my heading reversed forever. And recently, when I added the other simulation.
Here's one.
Here we go. So yeah, so there, I missed it, but when it approached that, it definitely, with a right angle, with a single scan line, suddenly, boom, everything disappears. But with the curved sensor, you get information that allows you to make that turn.
Ah, okay, so you're saying you're not using a straight sensor, you're using a curved sensor.
Right, at least that's the
Faint-
priority sensor.
Faint green hemisphere thing.
Okay, but that was my question. What, you have to be looking at individual pixels that make up that curve.
Right.
In the array of,
Right, so yeah, I am, in that case, I'm reading from the frame buffer all the pixels that intersect with that curve.
okay, yeah.
So, or more or less. I mean, what I'm doing is I generate a sampling. Actually, I have a lookup table with XY coordinates of pixels that are defined by that arc,
Right.
just to
okay.
save time.
Yeah.
And so in that, so I use I use a little circle generator, little trig to generate the XY coordinates, samples,
Yeah.
more or less a pixel apart, maybe a little more,
Uh-huh.
but roughly a pixel apart. So I'll have whatever, probably 300. In fact, I pass that information to the same processor that processes the horizontal lines. So my thought is that semicircle, I probably generate, in this case, I think the resolution is 320 by 240 for the little
Yeah.
sample images that are being captured. So in that case, I generate roughly 320 samples in this circle, and then flatten it out, send it to the processor that gives me the intersections. And that's what you're seeing, those funny looking bar graphs. You can see right now what it's seeing as far as the intersections of the sample scan line with the whatever. It's sort of like a little not histogram, more or less a histogram.
So the bottom row on the green is the semicircle.
Yeah.
Yes.
Okay.
Yes, and in there too, I'm looking, what you're seeing kind of hard to read, but I'm reporting a primary delta from the center line or my heading. So I have how far the line is offset in pixels from the center. So perfect straight on when I'm driving where I want to go with 0. And I have up to 2 intersections that I record. So I'll have a primary, like if I see a line intersection almost straight ahead, but if I have another one off to the right, I report that. So my decision processor can look at all that information and determine what it should do. And I'd be hard pressed to tell you the whole chain of events right now. Since a lot of this code has been written, I don't know how many years ago. Anyway, that's the deal, so that's it.
Cool.
Very good.
Nice.
If I had my VR stuff, we could play with some other cool stuff. I think that's, yeah, I don't know. Geez.
So does this mean that November, we're gonna see a line following
Oh.
robot and
And-
a six can?
Oh, maybe.
Okay.
Doesn't happen